Hey guys, so this video is about quadratics. In this video, we'll discuss everything that comes in quadratics for A-level maths for CIE paper code 9707. This video is specifically for Pure Maths 1. So all of the quadratics questions that come in Pure Maths 1 are included in this video. I've taken past paper questions from 2018 to 2025. In this video, you will see all of the different type of questions you can get for this topic, along with the difficulty level, which questions are going to be easy for you to solve and which ones are going to be slightly harder. So let's start with these questions and try to develop better understanding for quadratics. So I'm going to go from 2025 backwards to 2018. So this question came in 2025. It says use completing the square to find the exact solutions of the equations of the equation 4x squared minus 4x minus 1 equals to 0. So using completing square, you will solve this quadratic equation. So first you will take the 4 common from the entire equation because you want the coefficient of x squared to be 1. So that leaves us with x squared minus x minus 1 over 4 equals to 0. So that's going to be x squared minus x minus 1 over 4 equals to 0 because when you divide 0 by 4, it becomes 0. Now we use completing square method to find the solutions for this equation. So we have to complete this into a complete square. A complete square is a minus b whole square, which expands to a square minus 2ab plus b square. What we're trying to find is our b square value. So what we're going to do is we're going to see what is our a value based on the given equation. So we know x square is a square, negative 2ab is negative x, and plus b square is what we're trying to find. Negative 104 is not our b square. So to find our b value, we can put x equal to 2ab, where we know that a is x, so x equals to 2xb. So b is going to be x divided by 2x, which is 1 over 2. Which means over here, we'll write x squared minus x plus 1 over 2 squared because it's b squared. And then you write minus 1 over 2 squared as well. And negative 1 over 4 comes as it is. The reason why I wrote minus 1 over 2 squared is because when you're adding something new to the equation, we're supposed to subtract it as well. Since 1 over 2 squared is new in the equation, so if we're adding it, we subtract it as well like we did over here. So now it's going to be rewritten as x minus 1 over 2 whole square, where a is x and b is 1 over 2, and then negative 1 over 4 minus 1 over 4 equal to 0. So that's x minus 1 over 2 squared minus 2 over 4, which is negative 1 over 2. So x minus 1 over 2 squared equals to 1 over 2. We square root both sides to get rid of the square. So that's going to be x minus 1 over 2 equals to plus minus root of 1 over 2. So one value of x is going to be positive root 1 over 2 plus 1 over 2. And the other is going to be negative root 1 over 2 plus 1 over 2. Since they wanted exact solutions, so we don't convert it into decimals. So these are the exact solutions of the given quadratic equation. Then they're saying, hence solve the equation 4 tan theta equals to 4 plus 1 over tan theta, for theta is less than 180 and greater than 0. So if we compare this equation with the equation given in part A, I think they're the same because when it says hence, it means that you have to use your answer from the previous part. So let's rewrite this as 4 tan theta minus 4 equals to 1 over tan theta. Cross multiply the tan theta, so that's going to be 4 tan theta squared minus 4 tan theta equals to 1. 4 tan square theta minus 4 tan theta minus 1 equals to 0. So if we compare this with this, it's exactly the same. Now instead of writing x, we're writing tan theta. So to find the value of theta over here, tan theta equals to x, which means tan theta equals to positive 1 over 2 root plus 1 over 2, and then tan theta also equals to negative root of 1 over 2 plus 1 over 2. So theta is going to be tan inverse of these two. We just plug this in the calculator and that gives us 50.36 degrees. And for the other one, we're going to get negative 11.70 degrees. Now we know tan is negative in the second quadrant and the fourth quadrant. But obviously our angle is supposed to be between 0 and 180, so we focus on the second quadrant only. So negative 11.7 over here, we want this value. So it's going to be 180 minus 11.7, and that gives us 168.3 degrees. So these are your two values of theta based on the given range. If your angle is negative for the given trig ratio, like for example, in this case, it's tan. So you need to know where tan is positive and negative. Tan is positive in the first and the third quadrant, and it's negative in the second and the fourth quadrant. So since our angle is restricted between 0 and 180, so we focus on the second quadrant. Angle is always measured from the positive x-axis in anti-clockwise direction towards the line where the reference angle is. So we do 180 minus 11.7, that gives us 168.3. So that is the other angle. And also in these type of questions, you need to be able to recognize how the equation, the second part is similar to the equation, the first part. So once we rearranged it and brought everything on one side, we noticed that it's exactly the same as the quadratic equation given in part A, which means x is the same as tan theta. So when you put tan theta equals to x, we already have the solutions for x from the previous part. So we put it equal to tan theta and find the value of theta. Then you can get a question where it says find the coordinates of the points of intersection of the curve and the line with equations. So they can give you a quadratic equation and they can give you a linear equation, and you have to find the intersection of those two equations. So what you do is you substitute the linear equation, the quadratic one. I'm going to make y the subject over here in the linear equation. So y equals to negative 2x minus 4. This is your third equation. So we substitute third equation in the first one. This is the first equation. This is the second equation. Once again, you rearrange the linear equation, make one of the variables the subject, and then substitute that equation, the quadratic one. So now wherever there is y in the quadratic equation, I'm going to replace it with the third equation. So 2x bracket negative 2x minus 4 plus 5 bracket negative 2x minus 4 whole square equals to 24. Expand the bracket. Negative 4x squared negative 8x plus 5 bracket negative 2x minus 4 times negative 2x minus 4. Negative 4x squared minus 8x plus 5 bracket 4x squared plus 8x plus 8x plus 16. Negative 4x squared minus 8x plus 5. Collect the like terms. So that's going to be 4x squared plus 16x and plus 16. Then we're going to expand the bracket and multiply 5 with all of the terms inside the bracket. That's going to give us 20x squared plus 80x plus 80 equals to 24. Collect all of the terms on one side and collect the like terms. So negative 4x squared plus 20x squared minus 8x plus 80x plus 80 minus 24 equals to 0. That's 16x squared plus 72x plus 56 equals to 0. Now we solve this quadratic equation to find the values of x. This can be simplified because 16, 72, and 56 all come in the 8 times table. So that's going to be 2x squared plus 9x plus 7 equals to 0. When factorizing this quadratic equation, you can use splitting the middle term or the quadratic formula, whichever way is easy for you to solve. I'm going to be splitting the middle term, 2x squared plus 7x plus 2x plus 7 equals to 0. Use factor by grouping. So we're going to split the equation to two groups. The first two terms make one group and the last two terms make another group. In the first group, we have x common. So 2x plus 7 comes in the bracket. And the last group, we have 1 common. So again, 2x plus 7 comes in the bracket. Factorizing a quadratic equation, solving it is something that you have already learned in IGCSE. So this isn't something that you should be worried about. You covered in your O levels, IGCSE, whichever exam you gave. This base is already covered. So this isn't something new. So now between x and 1, we have 2x plus 7 common. So 2x plus 7 bracket x plus 1 equals to 0. X equals to -1 and x equals to -7/2. Now we have to find the corresponding values of y. So y was -2x minus 4. So y equals to -2 times -1 minus 4. That's 2 minus 4, and that's -2. And then for the other x value, y equals to -2 bracket -7/2 minus 4. That's 7 minus 4, and that is 3. So when x is -1, y is -2. When x is -7/2, y is 3. These are your values of x and y for the given equations. If you're someone who struggles with solving a quadratic and a linear equation, I'm attaching a link above. In that video, you'll come across several questions which will help you in developing your base for these type of questions. Then this is the equation of a curve is 2x squared minus kxy plus 2 equals to 0. And the equation of a line is y equals to px plus 3, where k and p are constants. Given that k equals to 2 and p equals to 11, find the coordinates of the points of intersection of the curve and the line. So this is very similar to the previous question, but the only difference now is that we have a k and p, and we have to substitute their values first in the equation, and then we solve it simultaneously like we did in the previous case. So let me show you how to do that. So 2x squared minus 2xy plus 2 equals to 0 is your first equation. Second equation is y equals to 11x plus 3. Now we substitute y in the first equation. So substitute 2 in 1. So 2x squared minus 2x times 11x plus 3 plus 2 equals to 0. If you're wondering why aren't we making x the subject and substituting that into the quadratic equation, you can also do that, but it's always best to stick to the given equation or like an equation where there are no fractions. Because if I had made x the subject, then it would be y minus 3 over 11. And then you would be substituting this fraction in place of x, which would make your calculation more difficult. So your job is to choose that method which makes the calculation easier. So that's why go with the equation where there is no fraction. So 2x squared minus 22x squared minus 6x plus 2 equals to 0. Negative 20x squared minus 6x plus 2 equals to 0. I'm going to divide all of them by -1 to make the x squared positive. So that's going to be 20x squared plus 6x minus 2 equals to 0. We can simplify this by dividing everything by 2. So that's going to be 10x squared plus 3x minus 1. Let's factorize this. 10x squared plus 5x minus 2x minus 1 equals to 0. In the first two terms, we have 5x common, so 2x plus 1 comes in the bracket. In the last two terms, we have negative 1 common, so 2x plus 1 comes in the bracket. Between 5x and negative 1, we have 2x plus 1 common. So 5x minus 1 goes in the other bracket. So now x equals to negative 1 over 2 and x equals to 1 over 5. Now we have to find the corresponding y values. So y was 11x plus 3. So at x equals to negative 1 over 2, y is going to be 11 times negative 1 over 2 plus 3, negative 11 over 2 plus 3, and that's going to be negative 5 over 2. At x equals to 1 over 5, y is going to be 11 times 1 over 5 plus 3. That's going to be 11 over 5 plus 3, and that is going to be 26 over 5. So when x is negative 1 over 2, y is negative 5 over 2. When x is 1 over 5, y is 26 over 5. So negative 1 over 2, negative 5 over 2, 1 over 5, and 26 over 5. Then it says, given instead that p equals to 4, find the set of values of k for which the curve and the lines do not intersect. So in this question, they have included discriminant. So let's go back to the initial equation. They're saying p is 4. So y equals to px plus 3. So now it's going to be y equals to 4x plus 3. And for the quadratic equation, 2x squared minus kxy plus 2. Okay. So they're not intersecting, which means we're going to use p squared minus 4ac less than 0 because there's no intersection. So you substitute y into the equation. So 2x squared minus kx times 4x plus 3 plus 2 equals to 0. 2x squared minus 4kx squared minus 3kx plus 2 equals to 0. A is your coefficient of x squared, B is your coefficient of x, and C is your constant. So based on this, A is 2 minus 4k, B is negative 3k, and C is 2. So let's substitute these in this inequality. So negative 3k squared minus 4 times 2 minus 4k times 2 is less than 0. 9k squared minus 8 times 2 minus 4k minus 16 plus 32k is less than 0. So we have 9k squared plus 32k minus 16 less than 0. So we have a quadratic inequality. Now we're going to solve this quadratic inequality to find the set of values for k. So 9 times 16 is 144. Factors of 144 other than 9 and 16 are 12 times 12, 1 times 144, 72 times 2, 36 times 4. We know 36 minus 4 is 32, so let's just use that. Between 9k squared and 36k, we have 9k common. So we have k plus 4 in the bracket. Between negative 4k and negative 16, we have negative 4 common. So again, k plus 4 in the bracket. So between 9k and negative 4, we have k plus 4. So 9k minus 4 goes in the bracket. So now let's draw our rough graph where negative 4 is over here and 4 over 9 is over here. Since the quality is less than 0, we look at the behavior of the x-intercepts. beneath the x-axis. So over here. So over here, we can say that -4 is increasing and 4/9 is decreasing. And since the values are converging, it's going to be a joint inequality, which means k is less than 4/9, but greater than -4. This is your set of values for k. If it was greater than 0 for the quadratic inequality, you would look at the behavior of -4 and 4/9 above the x-axis. So in that case, at -4, k would be decreasing, and at 4/9, it would be increasing. Then you would have two separate ranges instead of a joint one. Then since the equation of a curve is y equals to 1/2 k square x square minus 2kx plus 2, and the equation of a line is y equals to kx plus p, where k and p are constants, with k is less than 1 but greater than 0. It is given that one of the points of intersections of the curve and the line has coordinates 5/2 and 1/2. We have to find the value of k and p and find the coordinates of the other point of intersection. This is very similar to the previous questions, but I would still like to do this because it's slightly different when it comes to the solving part. So they have given us the points of intersection. They have given us the equation of the line and the curve. They want us to find the value of k and p and the other point of intersection. So let's put the point of intersection in the two equations and create an equation just in terms of k and p. Because it's a point of intersection, so it's shared between both the curve and the line. So 1/2 equals to 1/2 k square times 5/2 squared minus 2k times 5/2 plus 2. Let's simplify this first. So 1/2 equals to 1/2 times 25/4 times k square minus 5k plus 2. So that's going to be 25/8 k square minus 5k plus 2. If we multiply the entire equation by 8 to get rid of the fraction, that's going to be 4 equals to 25k squared minus 40k plus 60. 0 equals to 25k squared minus 40k plus 16 plus 16 minus 4. And that's going to be 12. Okay, so this is our quadratic equation just in terms of k. We can solve this to find the value of k actually. So 0 equals to 25 times 12. That's going to be 300. And factor of 300 that we can use to replace 40 is 30 times 10. Because 30 plus 10 is 40. So negative 30k minus 10k plus 12. Between 25k square and 30k, we have 5k common. So 5k minus 6. Between 10k and 12, we have 2 common. So negative 2 bracket 5k minus 6. So 5k minus 6 bracket 5k minus 2. So one value of k is 6/5 and the other is 2/5. They said that k is between 0 and 1. So 6 divided by 5 is obviously greater than 1. So this is not applicable. So to find the value of p, y equals to, let's use the linear equation. That's kx plus p. We have x, we have y, we have k. So 1/2 equals to 2/5 times 5/2 plus p. 1/2 equals to 1 plus p. 1/2 minus 1 equals to p, which is negative 1/2. So P is -1/2 and K is 2/5. These are your values of K and P. Now for the coordinates of the other point of intersection, so we have y equals to kx plus p, so 5/2x minus 1/2. And the other one was y equals to 1/2 k squared x squared. Let's write it over here. Y equals to 1/2 k squared x squared and minus 2kx plus 2. So that is going to be y equals to 1/2 is 2/5. 2/5 squared x squared minus 2 times 2/5x plus 2. So that's going to be 2/25x squared minus 4/5x plus 2. You put the equations equal to each other. So 2/5x minus 1/2 equals to 2/25x squared minus 4/5x plus 2. Multiply both sides by 25. Collect all the terms on one side. So 0 equals to 2/25x squared minus 4/5x minus 2/5x plus 2 plus 1/2. That's going to be 2/25x squared minus 6/5x plus 5/2. To simplify this, we can multiply the entire thing by 50. I'm just going to take the space over here because I didn't add extra sheets in this. But that's going to be 0 equals to 4x squared minus 60x plus 125. Now we have to solve this quadratic equation. So that's going to be 4x squared minus 50x minus 10x plus 125. 2x is common, so 2x minus 25 and -5 is common, so 2x minus 25. So 2x minus 25 bracket 2x minus 5. So one value of x is 25/2 and the other value is 5/2. So we already know that one intersection point was 5/2, which was already given the question. So now y equals to 2/5 times 25/2 minus 1/2, which is going to be 5 minus 1/2, and that's going to be 9/2. So the other point is 25/2 and 9/2. That is your other intersection point. Then part B says it is given instead that the line and the curve do not intersect. Find the set of possible values of P. So if they want us to find possible values of P, that means K is the same. So we found K to be 2/5. So y equals to 1/2. So let's use this equation. Y equals to 2/25 x squared minus 4/5x plus 2. And linear equation is going to be y equals to 2/5x plus b. So since they're not intersecting, that means the discriminant is going to be less than 0. So let's use this information to find the values of p. Let's put both of them equal to each other first. So 0 equals to 2 over 25 x squared minus 4 over 5x minus 2 over 5x plus 2 minus b, which simplifies to negative 6x over 5 plus 2 minus b. So a is 2 over 25, b is negative 6 over 5, and c is 2 minus b. B squared minus 4ac is less than 0. So negative 6 over 5 squared, 4 times 2 over 25 times 2 minus b is less than 0. So that's 36 over 25 minus 8 over 25 times 2 minus b. Let's write it as a single fraction. So 36 minus 16 plus 8b over 25 is less than 0. So 36 minus 16 is 20. 20 plus 8b is less than 0. So 8b is less than negative 20. b is going to be negative 20 over 8. And that simplifies to negative 5 over 2. So p is less than negative 5 over 2. Then it says show that the curve with the equation x squared minus 3xy minus 40 equals to 0 and the line with the equation 3x plus y plus k equals to 0 meet for all values of the constant k. So for this, we're going to use b squared minus 4ac greater than 0 because they're intersecting and they're meeting for all the values of the constant k. Y equals to negative k minus 3x. Let's substitute this in the quadratic equation. So x squared minus 3x times negative k minus 3x minus 40 equals to 0. So that's x squared plus 3kx plus 9x minus 40 equals to 0. Collect the like terms. 10x squared plus 3kx minus 40 equals to 0. A is going to be 10, B is going to be 3k, and C is going to be negative 40. We're going to use b squared minus 4ac is greater than 0. So 3k squared minus 4 times 10 times negative 40 is greater than 0. So that's 9k squared plus 1600 is greater than 0. So since we can't further solve it because when we bring this over here, it's going to be negative 1600 and k squared greater than negative 1600 divided by 9. We can't take the square root of a negative number. So this shows that, yes, that the curve with equation x squared minus 3xy minus 40 equals to 0 and the line with the equation 3x plus y plus k equals to 0 meet for all values of the constant k. Then the next type of question you can get is that the equation of a curve is y equals to 2k minus 3x squared minus kx minus k minus 2, where k is a constant. The line y equals to 3x minus 4 is a tangent to the curve. Find the value of k. So there are three cases. First case is that they don't intersect, which is the discriminant is less than 0. If they intersect, that means it's greater than 0. And if it's tangent, like the line is tangent to the curve, that means it's equal to 0. So over here, we're going to use b squared minus 4ac equal to 0. That's why it says find the value of k, not a set of possible values of k. So let's put the equation equal to the curve. 3x minus 4 is equal to 2k minus 3x squared minus kx minus k minus 2. Bring everything on one side. So 2k minus 3x squared minus kx minus 3x minus k plus 2 plus 4. Collect the like terms. That's plus 6. A is going to be 2k minus 3. B is going to be negative k minus 3. And C is going to be negative k plus 6. So b square minus 4ac equals to 0. So that's negative k minus 3 squared minus 4 times 2k minus 3 times negative k plus 6 is equal to 0. Expand the bracket, negative k minus 3 times negative k minus 3, 8k minus 12 times negative k plus 6. K square plus 3k plus 3k plus 9, negative 8k square plus 48k. Let's simplify this first because all of them come in the 9 times table. So k square minus 6k plus 9 equals to 0. 3 times 3 is 9. So k square minus 3k minus 3k plus 9 equals to 0. K bracket k minus 3 bracket k minus 3 equals to 0. K minus 3 times k minus 3. So we can square the two. K minus 3 equals to 0 and k is 3. That is the value of k. Then let's express 16x squared minus 24x plus 10 in the form of 4x plus a whole square plus b. So since in this case the coefficient of x is not 1 in the bracket, so that means we don't take 16 common from the entire equation. So it's going to be 4x whole squared minus 2 times 4x, and 2 times 4 is 8. 8 times 3 is 24. So b value is 3. So plus 3 squared minus 3 squared and plus 10 comes as it is. The steps are exactly the same. What's different is that we're not taking 16 common from the entire equation. So that's going to be 4x minus 3 whole square minus 9 plus 10, which is going to give us plus 1. So a is negative 3 and b is positive 1. That is your answer. Then it says it is given that the equation 16x squared minus 24x plus 10 equals to k, where k is a constant and has exactly one root. We have to find the value of this root. Then it says it is given that the equation 16x squared minus 24x plus 10 equals to k, where k is a constant, has exactly one root. Find the value of this root. So if it has exactly one root, that means it's tangent. So we're going to use b squared minus 4ac equal to 0. When it says it's tangent on, when in the question when it says the curve is tangent to the line or has exactly one root, you use b squared minus 4ac equals to 0. So 16x squared minus 24x plus 10 minus k equals to 0. A is 16, b is negative 24, c is 10 minus k. So it's going to be negative 24 squared minus 4 times 16 times 10 minus k equal to 0. 576. Then we do 4 times 16 times 10, 640, and plus 64k. 576 minus 640 is negative 64. We take the negative 64 to the other side, so it's 64, k equals to 64. K is equal to 64 divided by 64, and that is k equals to 1. That is your answer. That is your value of k, so now you find the value of the root. So it's going to be 16x squared minus 24x plus 10 equals to 1. So 16x squared minus 24x plus 9 equals to 0. We have to factorize this equation. Sixteen times 9 is 144. Factors of 144 that we can use to replace 24 is 12 times 12. So 16x squared minus 12x minus 12x plus 9 equals to 0. 16x squared and 12x have 4x in common. So 4x bracket 4x minus 3. 12x and 9 have again 3 in common. So that's going to be 4x minus 3 equals to 0. 4x minus 3 bracket 4x minus 3 equals to 0. That's 4x minus 3 squared equals to 0. So 4x minus 3 equals to 0, x equals to 3 over 4. That is the value of the root that they're asking for. For this, I think they should have given more space because we had to find the value of k first with the discriminant and then the value of the root. So basically, this is your answer. Then it says a line has the equation y equals to 3x plus k and a curve has the equation y equals to x squared plus kx plus 6, where k is a constant. Find the set of values of k for which the line and the curve have two distinct points of intersection. Two distinct points of intersection means that it's going to be b squared minus 4ac greater than 0. So first step is the same, put the equations equal to each other because they have a point of intersection. So 3x plus k equals to x squared plus kx plus 6. Bring everything on one side. X squared plus kx minus 3x plus 6 minus k. A is 1, B is k minus 3, and C is 6 minus k. K minus 3 whole square minus 4 times 1 times 6 minus k is greater than 0. K square minus 6k plus 9 minus 24 plus 4k is greater than 0. K square minus 2k minus 15 is greater than 0. Factorize it. K square minus 5k plus 3k minus 15 is greater than 0. K bracket k minus 5 plus 3 bracket k minus 5 is greater than 0. So k minus 5 bracket k plus 3 is greater than 0. So since it's greater than 0, negative 3 over here, 5 over here, we look at the behavior above the x-axis now. So at 5, it's increasing. At negative 3, it's decreasing. So k is less than negative 3 and k is greater than 5. So we have the values of k. So the question was asking us to find the set of values of k, and that's what it's going to be. Then it says by using a suitable substitution, solve the equation. So this is another type of question you can get for quadratics. It says 2x minus 3 whole square minus 4 over 2x minus 3 whole square minus 3 equals to 0. So the question has clearly identified that we have to use a suitable substitution. So you don't need to expand the brackets and solve it. So we can assume that two x minus 3 equals to y. So it's y squared minus 4 over y squared minus 3 equals to 0. So that's going to be y to the power of 4 minus 4 minus 3y squared equals to 0. So y to the power 4 minus 3y squared minus 4 equals to 0. To make this further simple, you assume that y squared is a. So now it's going to be a square minus 3a minus 4 equals to 0. So using this equation, first we find the value of a. Using that, we find the value of y, and then we go to 3. And then we go to the value of x. So it's a step-by-step thing. So if factorize this, a square minus 4a plus a minus 4 equals to 0. A bracket a minus 4 plus 1 bracket a minus 4 equals to 0. A minus 4 bracket a plus 1 equals to 0. So a is equal to 4 and a is equal to negative 1. We have values of a first. So now we put these in y square equals to a. So if y square equals to 4, y would be root of 4, which is plus minus 2. And if y square equals to negative 1, we can't solve that, so not applicable. Now y was equal to 2x plus or minus 3, minus 3. So 2 equals to 2x minus 3. 2 plus 3 equals to 2x. 5 equals to 2x. So x equals to 5 over 2. And then we put the other value of y. So negative 2 equals to 2x minus 3. Negative 2 plus 3 equals to 2x. 1 equals to 2x. 1 over 2 is the other value of x. So you solved your equation using two substitutions, and that gives you the value of x. Then another thing you can get for completing square form is they can mix it up with transformations. So in the first part, they're asking you to convert the quadratic equation to completing square form. So the quotient of x squared is already 1, so we don't need to take anything common. It's going to be x squared plus 2 times x. B is going to be 3 because 2 times 3 gives us 6. So plus 3 squared because plus b squared will complete the square. Minus 3 squared because we have to subtract something if you're adding something new. And then plus 5 comes as it is. So that's x plus 3 whole square minus 9 plus 5. X plus 3 whole square minus 4. A is 3, B is negative 4. Then says the curve with equation y equals to x squared is transformed to the curve with equation y equals to x squared plus 6x plus 5. Describe fully the transformations involved. So y equals to x squared plus 6x plus 5 is basically the same as y equals to x plus 3 squared minus 4. So they're saying that y equals to x squared was transformed to this one, which is the same as y equals to x plus 3 squared minus 4. So looking at the equation, we can see that we have a vertical translation of 4 units down. Then we have a horizontal translation of 3 units to the left. So the graph has shifted 3 units to the left and 4 units down. So these are the transformations that have taken place in this quadratic curve. Then another one that you can get for substitutions is something like this. It says solve the equation ln 3 plus ln 2x plus 5 equals to 2 ln x plus 2. So for this, you need to know about your rules of logarithms. So ln 3 plus ln 2x plus 5 equals to 2 times ln x plus 2. First, we'll bring the coefficient as a power of the bracket. So it becomes ln 3 plus ln 2x plus 5 equals to ln x plus 2 whole square. When two ln's are being added, we can rewrite it as a single log where the numbers are multiplied. So it can be rewritten as 3 bracket 2x plus 5. We're multiplying them. So when there's an ln on both sides of the equation existing singularly, we can cancel those out. And it's going to be 6x plus 15 equals to x plus 2 whole square. Then you expand the bracket, which is going to be x squared plus 4x plus 4. Collect everything on one side. X squared plus 4x minus 6x plus 4 minus 15. X squared minus 2x minus 11. Now we factorize this quadratic equation. We'll use the quadratic formula this time because we can't factorize just using splitting the middle term. X equals to negative 2 plus minus root of negative 2 squared minus 4 times 1 times negative 11 over 2 times 1. So that's 2 plus minus 4 plus 44 over 2, which is 48. We can't take square root of 48, but we can factorize it. That's 6 times 8, which can be rewritten as 3 times 2 times 4 times 2, which will again be 3 times 4 times 4. So that's going to be 2 plus minus 4 root 3 over 2. So one value of x is 2 plus 4 root 3 over 2, which simplifies to 1 plus 2 root 3. Other is going to be 2 minus 4 root 3 over 2, which is 1 minus 2 root 3. So these are exact solutions of x. Then it says showing all necessary working, solve the equation 4x minus 11x to the power of 1 over 2 plus 6 equals to 0. So again, the substitution thing. We're going to begin with assuming that x to the power of 1 over 2 equals to y. So that means x to the power of 1 over 2 being squared will equal to x, which will equal to y squared. So it's going to be 4y squared minus 11y plus 6 equals to 0. Using this quadratic equation, first we'll find the value of y and then use that to find the value of x. 4 times 6 is 24. Factors of 24 which we can use to replace 11 is 8 and 3. So 4y squared minus 8y minus 3y plus 6 equals to 0. In the first two terms we have 4y common. So y minus 2 in the bracket. In the last two terms we have negative 3 common. Y minus 2 in the bracket. 4y minus 3 bracket y minus 2 equals to 0. One value of y is 3 over 4 and the other is 2. X to the power of 1 over 2 was equal to y, which means x to the power of 1 over 2 equals to 3 over 4 and equals to 2. To find the value of x, we're going to square 3 over 4 and 2. That's going to give us 9 over 16 and x equals to 4. These are your two values of x, and with that we're done with the questions for quadratics. This was everything that comes in quadratics for Pure Maths Paper 1, A-Level Maths for Cambridge CIE, paper code 9709. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in the playlist, which I'll be uploading soon. And in the comments, I've also uploaded a link to the entire document that has these questions from 2018 to 2025. So I haven't solved all of these questions because most of them were similar, but you can always use that document to practice more for quadratics.